The first problem we're going to look at is the allowance project that you did. We're going to determine which is better, linear or exponential, and when it is better. You know from this project that exponential is better in the long term, but if we were talking about 10 days or 20 days, which one is it better? The best way to figure this out is by using your graphing calculator. First, I wrote the two equations. The linear equation would be 100 times the number of days. So at 10 days, you'd have $1,000. The exponential is 0.005 because we were saying 1 penny for the first day. So if we go back to the 0th day, that's how we'd represented it, times 2 to the dth power, because you're doubling it every day. So using the graphing calculator, I just typed those into my y equals. They're just the same equations. Then I went to my table setup, which is second window. I started at day 1 and going by 1 for each day. Then I hit second graph to go to my table, and I scrolled down till I got to day 19, which says at day 19 you would receive $1,900, and on the exponential one, you would receive over $2,600. Obviously, the $2,600 is better. If we sum them up, it might not be better, but at this point, given this day, the $2,600 is better. So after 19 days, you would probably want to switch which method that you received your payments in. Next, I'm going to give you something of an inequality shaded region on a graph. And some things you're going to have to remember to do for this is, what is the equation of a horizontal line? As you know, the equation of a horizontal line is y equals whatever number. In this case, I said y equals 4. It'd be y is greater than 4 if you shade above the line. Y is less than 4 if you shade below the line. Remember, if the line is solid, then we do greater than or equal to, and less than or equal to accordingly. Then you're going to have to also be able to write an inequality. Remember, to write an inequality is no different than writing a line. Find the slope, use a point on that line. Yes, you could use y equals mx plus b, but I have always found that this is usually more helpful because you're often not given the y-intercept. To choose your inequality, test a point in the shaded region and choose the inequality that makes that a true statement. Finally, you have to give me a situation where this might be used. You all might remember the heart rate problem where you had to be between ages, I don't remember exactly, but it was like 14 and 70, and your heart rate had to be between 75 and 90% in order for it to be in a target heart range for the best possible workout. Next, I'm going to give you different domains, and within those domains, you're going to have to give me a real life situation. So for example, if I had all real numbers, I could use that as time at a football game because the time can be various different numbers. Whole numbers, obviously we can't have a fraction or a decimal, so maybe the number of muffins sold at a bake sale. Next, irrational numbers. Remember, irrational numbers are numbers that never end or repeat. They're usually square roots or, of course, pi. So in this case, I said the side length of a square that are not perfect squares. So they would all be a square root number. Next, if I give you a specific point, in this case 20, 100, I said if 20 students make 100 hats at school, that would be a specific situation. Next, I'm going to give you a graph like this, and you are going to have to come up with a story. So you could say he started off at home delivering some newspapers to his neighbors and sped up to 10 miles an hour where he stayed. Then he was going down a faster street and going a little faster, up to 30 miles per hour, but then had to slow down to, say, drop off a few more papers, or just maybe one in this case. And then he sped up to 40 and finally 50 miles per hour. Population. You're going to have to write an equation. Remember, population in this case, since it's doubling every year, is exponential. So you would just write the current population, whatever number that is, times 2 to the x power. You would use the positive numbers for the x value for the future and the negative numbers for the past. If I give you a sequence, I would like you to model it using function notation. And in this case, what I did is I said f of x equals 5 to the x minus 1. Because 5 is our first term, not our 0th term, that's why I did the x minus 1. You could find the 0th term, which would be 1, and then it would be 1 times 5 to the x power, because your 5 is what you're multiplying by each time, and the coefficient, the number in front, is what it would be each time. If you notice, I put in 1 here, I will get out 0. Anything to the 0th power is 1, and then 5 being my first term will give me 5 as my first term here. Comparing these two functions, it means if I have any function, how are they the same and how are they different? In this case, they're the same function, but the second one is shifted up 3 units. Next, if I give you some points, you have to write equations, both linear and exponential. The linear one, you just find the slope, write the equation in a line. That should be pretty basic. For the exponential, I will give you either the 0th term or a couple terms real close together. In this case, they're 2 apart because I'm going from 0 to 2. And then from 5 to 45, I'm just multiplying by 9. Since I'm doing that in 2 steps, if I wanted to find the first term, I would first multiply by 3. 5 times 3 is 15. And then 15 times 3 is 45. So my equation is y equals 5, my starting value, times 3 to the x. This is another population problem. It's a little different because it's growing at a percentage rate instead of doubling. And I actually gave you here the starting value of the town. So there's my equation. F of x equals 6,000 times 1.016 to the x power. I added 1 because I want 100% plus 1.6% more. You would then use -3, -2, -1 for the past, and 1, 2, 3 for the future population. Then you're going to have to explain to me which functions are growing faster. And as you know, linear grows slower than exponential long term. Good luck on your test tomorrow. I will take any questions, and you can always email me ones that you think of in the future.